Okay, this is the second half of the Chapter 12, Section 6 video. And here in your student journal on exercises 5 and 6, they're asking you to decide whether you can use the given information to prove these two triangles are congruent. And this time, what you'll notice is they didn't give you triangles. So the best thing for you to do is go ahead and draw two triangles. And we're going to draw them so that they look congruent, even though we don't know if we have enough information yet. And then we're going to label them LMN, LMN, and PQR, being sure that L and P are in the same position, M and Q are in the same position, and N and R are in the same position. And then we're going to fill in what they gave us. They're telling us angle M is congruent to angle Q. So I'm going to mark angle M congruent to angle Q. Then they give us angle N is congruent to angle R. Here's angle N and angle R. Then they give us one set of sides. NL, that's this one, is congruent to RP. And is that enough to prove the triangles are congruent? It is, because we have two angles and a side. So is it angle, side, angle, or is it angle, angle, side? Well, is the side in between the two angles that are congruent? No, it's over here on the outside. So the answer is yes by angle, angle, side. Now pause the video and try number 6. Pause it here. So hopefully you noticed when you labeled those two triangles that while there are two angles and a side, on this first triangle, the side is in between the two, and on the second one, the side is not in between the two angles. Also, these letterings don't match up with the way that the triangle was given to you in the congruent statement. So this one is definitely a no, mostly because I think what they did was they gave this to you out of order, LM and PQR. So that one doesn't work. Okay, we're going to move on to this where they start asking you to actually write the proofs. You're proving that two triangles are congruent, so you want to think about all the theorems that we've used to prove triangle congruence. The first one we learned was side, angle, side. Then we learned side, side, side. And then today we've learned angle, side, angle, and angle, angle, side. So those are the 4 theorems that we can use to prove triangles are congruent. We're going to look at this one and look at the information we have to decide which direction we want to go. They've given us 2 lines are parallel. And when we have 2 lines are parallel, we want to look for the Z pattern to see if we have alternate interior angles. So let's start there. I'm going to highlight my parallel lines. There's my parallel lines. And I have a Z pattern actually one of 2 ways, don't I? So I have one here, and I can get alternate interior angles right here and right here. And I'm just highlighting them because we're not actually doing the proof part yet. They also gave us BD is congruent to BC. So they had that marked. BD is congruent to BC. So we know we've got those alternate interior angles and we've got a side. So we have an angle and a side. When I look at this, I want to look to see, can I come up with any more angles or any more sides? I'm not sure about the sides. They look congruent, but nothing is marked and they don't share a side. When I'm looking at angles, I look for, do they share an angle or do we have vertical angles? Well, if we look right here at angle B, we've got vertical angles right there. So those 2 sets of angles, those 2 angles, not sets of angles, but those 2 angles are also going to be congruent because they're vertical angles. So then do I have enough to use any of those theorems? It looks like I have an angle and an angle and the side that connects them. So it looks like this is the theorem we ought to be using. You'll want to walk yourself through that whole proof if you can before you start writing anything down. And I made kind of a mess of everything, so I'm going to delete all of that. You can always trace over your shapes and draw as many of them as you want, so you can mark them up and then you can mark up a different one. I think that's helpful. Sometimes have multiple ones. So let's go ahead and get started with our proof. We start with the given. So we have AD is parallel to EC and BD is congruent to BC. That was given. Now we said since those two lines were parallel and we got that Z pattern, angle C was congruent to angle D. So angle C is congruent to angle D because we had the parallel lines and those two are alternate interior angles. So we can say parallel lines. If two lines are parallel, then the alternate interior angles are congruent. Now we have a side and an angle. We need to get that last angle, which are these two. Since you have so many angles coming off of point B, you need to call them by better names. So we're going to say angle ABD is congruent to angle EBC. And we can either say because vertical angles are congruent, or we could say the vertical angle theorem. Vertical angles are congruent. And that's all of our pieces. That's our angle, two angles, and the side that connects them. So now we've gotten to this proof part. We can say triangle ABD is congruent to triangle EBC by angle, side, angle. Okay, here we are with another proof. We're given some different information this time. It looks like we have a rectangle, but since it's not given to us, we don't want to jump to conclusions, but it looks like a rectangle. And we know HF is congruent to GK. No, they're parallel, not congruent. HF is parallel to GK. Angle F and angle K are right angles. And they're asking us to prove triangle HFG. So let's highlight that. HFG is congruent to triangle GKH. GKH. Now we know when we overlap those lines, we know that we can use that side is congruent to itself. So that automatically gives us a side. And we know F and K are right angles. And what do we know about all right angles? Well, we know all right angles are congruent. So we've got an angle and a side already right there, right off the bat. And then we know we had parallel lines. And anytime we have parallel lines, we want to look for that Z pattern. So here's our parallel lines, HF and GK. To get that Z pattern, we're going to come through here. So it looks like those angles are going to be this angle right here and this angle right here. So we have two angles and a side. At that point, we should be able to use either angle, angle, side, or angle, side, angle. So the question is this side that's the same in between the two angles? Well, it might be better for us to sketch one of these by itself. We have this angle here, GHF. We have this angle and this side. Aha, so it's the side that's not connecting them. So we're going to be using angle, angle, side this time. And it looks like that's all the information. So we've done all of our planning. We're ready to write the proof. We're going to start with our given. HF is parallel to GK. And angle F and angle K are right angles. And that's given. Now, what did we say? Since F and K are right angles, what do we know about them? Well, we know that they're congruent, and that's what we're trying to get to. We're trying to match a lot of congruent parts. Angle F is congruent to angle K, because all right angles are congruent. So we know that. Let's see, we had a side. We said GH was congruent to itself. So GH is congruent to GH. And what was that property? It's called the reflexive property. So now we have a set of angles and a set of sides. We need that other set of angles that we said we had because of that Z pattern. Let me clear this off so we can look at that again. Here's our Z pattern. So we have this angle and this angle. So let's name those carefully. FHG, angle FHG is congruent to angle KGH because of those parallel lines. So if two lines are parallel, then our alternate interior angles are congruent. So now we have two angles and a side. Let's look and make sure we've got those. Here's a set of congruent angles, a set of congruent sides, a set of congruent angles, and we said for this one it's angle, side. So we're ready to say what we were trying to prove. Triangle HFG is congruent to triangle GKH by angle,